Hello friends, today we are going to learn the algorithm for longest palindromic subsequence. So let's see some examples. Here is the first example. The string is ADBBCA and the LPS is ABBA and the length is 4. LPS means longest palindromic subsequence. Here is the second example. The string is PQRDRPD and the LPS is PRDRP and the length is 5. The third example PQRRQP and the LPS is PQRRQP. As the LPS is same as the string, this means that the string is a palindrome. So now I will tell you the algorithm for finding out the LPS. We are going to use dynamic programming here, and for dynamic programming we are going to use this memoization matrix. For populating the values in this memoization matrix, we are going to follow these 4 points. So I will explain you each of the points. So the first point tells us 2 plus diagonally previous cell. So I will explain what this means. I will take the help of this tree for explaining those 4 points. So the first point, here you can see this string ADBBCA. In this string, the first and the last character match. Means we can increase the length of the LPS by 2, and the problem drills down to find out LPS of this substring DBBC. Because the first and the last character match, we exclude these characters and the problem drills down to finding out the LPS of the substring DBBC. So here we can write 2 plus the LPS, length of the LPS of DBBC. So let's look into the matrix. Here you can see the index is 0 to 5. So here in the matrix 0 to 5. So it is this cell. Means the length of the LPS of this full string for which the index is 0 to 5 is represented in this cell. And the length of the LPS is dependent on the length of the LPS of DBBC, means the index 1 to 4, and we add 2 because the first and last character match. So here 1 to 4, so this is this cell. So the value of this cell depends on this cell, and we take value from this cell. We take value from 1 to 4, this cell. So I will point that value by a circle, plus we add 2. So 2 plus value from this cell. So this is what this first point means. Now the second point, max of cells. So here now further, D do not match with C. D and C don't match with each other. So our problem drills down to finding out the LPS between DBB and BBC. Means DBB this and BBC. So we have divided the string from index 1 to 3 and 2 to 4. So let's see here, 1 to 3 is this cell and 2 to 4 is this cell. So max of these two cells and the value will go in this cell, that is 1 to 4. means the value of index 1 to 4 depends on these two cells 1 3 and 2 4, means 1 3 and 2 4, and we take max between those two cells and we put the value in this cell, means we return the values and max will be the length of this LPS. Now let's go to the third point. Mark all diagonal cells as 1. As we move further in this tree, at the leaf level you can see there are only single characters, and as every single character represents the LPS of length 1, means a single character is already an LPS and its length is 1. So for all the diagonal characters, means this cell represents A, this cell represents D, this cell represents B, we mark the cells as 1 because every single character is LPS of length 1, and the elements below diagonal we represent them as 0. So because means all these elements below this diagonal are represented as 0 because these elements represent the string or a substring in reverse order. For example, this cell represents string from C to D. So we can see here from C to D, this goes in reverse order. So all the cells below this diagonal represent the string in reverse order. So we ignore these cells and we just populate 0 in those cells. So these are the 3 points, and the fourth point is the diagonal order. So what does this mean? So here if you want to find out the value for this cell, then for this cell B and A, they don't match, so we have to take the max of this cell and this cell. So for the max of these two cells, it is necessary that these two cells are already populated with their values. So you can see all these are in diagonal order. So now we will solve the real examples and you will understand the algorithm very clearly after we solve the examples. So let's solve some examples and see how the algorithm works. So here is our first example. The string ADBBCA is written along the column as well as along the row. The cells in the diagonal are already marked as 1. As you know, these cells represent the length of longest palindromic subsequence in a string when there is only one character in that string. So let's see. Let's go to this cell. So for this cell, the row element is A and the column element is D. So as we can see, they don't match. So here is the first step. When the characters don't match, then you have to take the max of these two cells. This means for this cell, if the characters don't match, then you have to take max of 1 and 1. So the max is 1. Now let's go to the next cell. As you know, we move diagonally. So D, B, they don't match. So max of 1 and 1 is 1. Then B and B, yes, they match. So the second step is that when two characters match, then take the diagonally previous element, that is 0, plus add 2, means we add 2 because as B and B match, we get 2 characters in the string which contribute to forming the palindrome. So we add 2. Now go to the next cell. B and C, they don't match, so max of 1 and 1 is 1. C and A, they don't match, so max of 1 and 1 is 1. So let's go to the next diagonal. So A and B, they don't match, so max of 1 and 1 is 1. D, B, so max of 1 and 2 is 2. B, C, they don't match, so max of 2 and 1 is 2. B, A, they don't match, so max of 1 and 1 is 1. Then A, B, they don't match, max of 1 and 2 is 2. Then D, C, they don't match, so max of 2 and 2 is 2. B, A, so they don't match, so max of 2 and 1 is 2. Now A, C, they don't match, max of 2 and 2 is 2. Then D, A, they don't match, max of 2 and 2 is 2. Now A, for this cell, A matches with A, so we have to take the diagonally previous element, that is 2 plus 2. Because A and A match, so we get 2 characters which contribute to forming the palindrome, so we add 2. So this is how we get the length of longest palindrome in the string. So the length of longest palindrome is 4. I will write it here. The length of longest palindrome is 4. So this is how the algorithm works. Now we will find that string. So let's find out that subsequence. So we will start at the end here. So now see, this cell value has come from a diagonally previous cell, that is this cell, which is why we have marked here a blue arrow which points to this cell. So always take the character to which the arrow is pointing. So this cell, the character is A and A. So our first character in the palindrome is A. So here, now this is an array I have declared for storing these characters. This is the start pointer and this is the end pointer. So let's write the character here, that is A. One at the start and one at the end. Now these pointers start move ahead and the end moves backwards. That is start equal to start plus 1, end equal to end minus 1. So let's see now. So by this direction of the arrow, we concluded that this cell value came from this cell. Now from where this value came? In the cell 1, 4. For this cell, the characters did not match, so obviously the value will be max of this 2 and this 2, means this cell and this cell. So max of 2 and 2 is 2, so you can move in any direction. So I have made a horizontal arrow. Now from where this 2 came? This 2 came from max of 1 and 2. So it came from this cell. So I have made a vertical arrow. Now from where this 2 came? So this 2 came because B and B were matching. So we made a diagonal arrow and we added 0 and 2. So this is a diagonal arrow which points in this cell. As there is a diagonal arrow which is pointing in this cell, so we have to take these characters, that is B and B. So we will write one B at the start and another B at the end. So this is how we find out the subsequence, the palindromic subsequence. So the palindromic subsequence in the string ADBBCA is ABBA. So this is how we find the subsequence. Now let's move to the next example here. So we have to populate the matrix first. So this cell A and D don't match, so max of 1 and 1 is 1. DB they don't match, so 1. BG don't match, so max of 1 and 1 is 1. GC they don't match, so max of 1 and 1 is 1. CF, so it's 1. I will write directly now. FB is 1. BE is 1. EA, so the max of these two cells is 1. So let's move to the next diagonal. AB, so they don't match, so max. DG they don't match, so max of 1 and 1 is 1. BC it's 1. GF it's 1. CB 1. FE it's 1. BA it's 1. Now AG is 1. DC it's 1. BF it's 1. GB 1. CE it's 1. Then FA it's 1. AC 1. DF it's 1. B, yes, so this is the cell. B and B match. So we have to take this element and we have to add 2 to it. Now to the next cell, GE, that's 1. CA, that's 1. AF is 1. DB they don't match, so max of this and this is 3. BE, max of this and this is 3. This 1 plus 2 is 3. Then GA they don't match, so max of 1 and 1 is 1. Then AB they don't match, max of 1 and 3 is 3. DE they don't match, max of 3 and 3 is 3. Then BA 3 and 1, max is 3. Then AE they don't match, so max of 3 and 3 is 3. DA max of 3 and 3 is 3. AA, yes, they match. So in this cell it will be 3 plus 2 because they match. So 3 plus 2 is 5. So for this string the length of LPS, that is longest palindromic subsequence, is 5. Now is the time to find out that longest palindromic subsequence. So now let's do that. The length of that subsequence is 5 and I have made a diagonal arrow here. So now as the length is 5, we have to define a character array of length 5 to store the elements. So the index is 0, 1, 2, 3, 4 and our start pointer points to this cell first and end pointer points to the last cell. This is the beginning. Now let's see. As there is a diagonal array pointing in this cell, so we have to take this character, that is A, and we have to put one at the start, another at the end. Now let's move ahead and end will come backwards. So let's search for another character. From where these 3 came? So these 3 came either from this or this cell. So we will go horizontally. Then from where these 3 came, max of 1 and 3, so it came from this cell. From where this 1 plus 2 came? Yes, here the character matched B to the B, so we had this diagonal array pointing in this cell. So we have to take this character B and B. Let's move ahead, start and end. Both will point to the same cell. Now when these 2 pointers point to the same cell, this means that the length of the longest palindromic subsequence is odd. Pay attention, here the length was even, the length is 4 and here the length is 5, so it is odd. So when the length is odd, the start and end pointer finally will come to a single cell. So now we have to find out that single character. So let's see how to find out that character. Now you can see from where this 1 came. Yes, it came from max of this and this cell. So as both are 1, we can make arrow from any of these cells. So I made it a horizontal arrow. Now from where this 1 came, it came from max of 1 and 1, so I make a horizontal arrow. Now for this cell you can see G and G match with each other, and this is the diagonal element, that is it is in the diagonal of this matrix. So we end here and the character which matches is G. So in case of odd palindrome, that one character we always get at the diagonal of the matrix, so we write G here. So this is how we find out that longest palindromic subsequence. So let's see the algorithm now. So here we have to declare all the diagonal cells of matrix as 1. So as you can see in this matrix, so in the program you have to declare all the diagonal elements as 1. Then for each cell above diagonal cell, so for each cell above this diagonal, we have to check whether str of I is equal to str of j. So this means that I is tracing the row, j is tracing the column. So str of I means the character in the row and character in the column. If these characters are equal, means for example this cell A is equal to A, then you have to take means you have to populate the value like matrix of ij equal to 2 plus matrix of I plus 1 j minus 1. I plus 1 j minus 1 means this cell, means if value in this cell is x, then here it will be 2 plus x. Else if they don't match, then matrix of ij is equal to maximum of, means for this cell they don't match, so it will be maximum of this cell and this cell, that is max of x and y. So here we can write it as max of matrix of I plus 1 j and matrix of I j minus 1. So this is the formula for the code or for the program, and the time complexity of the program is O of n square due to the two for loops we use for tracing the matrix. You can get the full program at this link, that is github.com/vivekanand44, and you can use the code for your work. Thank you.